And welcome back to our regular class. Um, Today we are going to learn about the different topics of heat. From the yesterday class we learned about the different types of thermometric liquid, and today among the different types of thermometric liquid most commonly used are mercury and alcohol. Mercury and alcohol shows the different types of property. So they are used as a thermometric liquid. The basic property shown by the mercury and alcohol, so that they are used as the thermometric liquid are like so in slide please. In thermometric liquid as the mercury, it is used because of the following properties like a good conductor of heat, uniform expansion and contraction, easily visible due to silvery shine, remains in liquid state over a wide range of temperature, that is freezing point minus 39 degrees Celsius and the boiling point 357 degrees Celsius. That means it can shows the temperature or read the temperature up to minus 39 degrees Celsius and up to 357 degrees Celsius. So, it is widely used for the high temperature thermometer. As the high temperature thermometer, it does not measure the temperature below the 39 degrees Celsius, as it freezes at 39 degrees Celsius. Similarly, its another property is low specific heat capacity, that is less amount of heat can expand and contract the mercury uniformly, and it does not wet the wall of capillary tube. That is the basic properties which are for which the mercury is being used. These two properties, that is low specific heat capacity and does not wet on the wall of capillary tube. Similarly, alcohol is used because of the following properties, and alcohol freezing point is minus 117 degrees Celsius. See that temperature, minus 117 degrees Celsius. That means it can be used as a low temperature thermometer. It can measure the temperature up to minus 117 degrees Celsius and its boiling point is 78 degrees Celsius. That means it cannot measure the temperature above the 78 degrees Celsius. Above 78 degrees Celsius, it itself vaporizes. That means we cannot measure the temperature of boiling water by using the thermometer. Why? Because the boiling point of water is 100 degrees Celsius and the boiling point of alcohol is 78 degrees Celsius. That means while measuring the temperature of boiling water, the alcohol itself get vaporized. So, it is hard or it is impossible to measure the boiling point of water by using the alcohol thermometer, and its major disadvantage is it is colorless. So, it should be colored before use, and it wets on the wall of capillary tube. Similarly, it cannot measure the temperature above the 78 degrees, means high temperature. So, it is widely used as low temperature thermometer, or we may say that it is very friendlier or it is very useful for the mountaineers, because in the mountains, high mountain ranges, the temperature may reach below the 50 or may reach below the minus 40 degrees Celsius, and at that temperature alcohol thermometer is used. So, there is one question, why is water not used as thermometric liquid? Why? Think a while, and its answer may be like, first of all, it does not show the uniform expansion and contraction. On heating the water, it does not show the uniform expansion and contraction. That is, in higher class you will learn about the anomalous expansion of water, and similarly its specific heat capacity is very high. The specific heat capacity of the water is 4200 joule per kg per degree Celsius. That means large amount of heat energy is required to either contract or expand the water through 1 degree Celsius. So, it is not widely used as the thermometric, or we may say that it is not used as the thermometric liquid. Now, construction and the calibration of thermometer. Before measuring the thermometer, using the thermometer, it is needed that how the thermometer is constructed and how it is calibrated. And the term calibration means scaling the thermometer. The scaling means the thermometer is scaled like 0 degree Celsius, 1 degree Celsius, 2 degree Celsius, 5 degree Celsius, how it is made. And all the thermometer are calibrated in a simple principle by measuring the lower point and by measuring the upper fixed point. That means for the water, if you take the example of water, then the water freezes at 0 degree Celsius and boils at 100 degree Celsius. And if you take that two temperature, that two different temperature, 0 degree Celsius will be the lower end of the thermometer and 100 degree Celsius will be the upper end of the thermometer, and you can make the ranges from 0 to 100 at any desired. For example, what does it mean by 1 degree Celsius? After fixing the lower fixed point and upper fixed point, that is 0 degree Celsius to 100 degree Celsius, if you divide that 0 to 100 in equal 100 parts, again if you fix lower fixed point and upper fixed point and divide that 0 to 100 into 100 equal part, one part is known as 1 degree Celsius. After this, we can divide the thermometer as our desired, that is called the calibration. So, in this slide you can see how the construction and the calibration of thermometer is done. First of all, uniform glass tube is taken, then one end is made blonde by heating and the reservoir like another end is made so that the mercury is filled inside it, and that end is called bulb. That end is called bulb. For measurement of the temperature, that bulb must get inserted or must be in touch with the body that the temperature is to be taken. Another one is filled with the mercury and close the opening end by heating, means that bulb is filled with the mercury. And the lower end and upper fixed point or upper fixed end is determined to make the scale on it, that the process is called calibration. You can see in the slide the distance between upper fixed point and the lower fixed point is divided into a equal number of parts depending upon the type of chosen temperature scale. As I already mentioned you that if you take the thermometer without calibration, then you can calibrate it like taking the standard temperature as melting of ice, that is 0 degree Celsius, or freezing of ice, that is 0 degree Celsius, then the boiling of water at 100 degree Celsius. If the lower fixed point is that 0 degree Celsius and upper fixed point is 100 degree Celsius, then you can divide that 0 to 100 into 100 equal parts. Then one equal part is known as 1 degree Celsius, or is may called as 1 degree Celsius. So, you can see in this slide, lower fixed point is the temperature of pure melting ice. See, lower fixed point is the temperature of the pure melting ice at normal pressure, and upper fixed point is the temperature of the pure boiling water at normal pressure. So, these 2 points are taken, then it is calibrated. And you can make the desired scales on the thermometer. So, in the figure you can see one is thermometer. The first figure is the thermometer which is ranged from 0 to 100 degree Celsius, That 0 to 100 degree Celsius is scaled by the second and third figure. In the second figure, there is boiling chamber. That boiling chamber helps to rise the mercury level to a fixed point. That fixed point is termed as 100 degree Celsius and it is upper fixed point. And another one is that the mercury filled thermometer is dipped in the funnel containing ice. That ice starts to melt and we will find a temperature. That temperature is 0 degree Celsius. After measuring the lower fixed point and upper fixed point, the thermometer is calibrated as shown in the figure first, that is 0 degree Celsius and 100 degree Celsius. Then you can make the different scales on that thermometer as your desire. Now, temperature scale. Temperature scale means, as we already mentioned that the temperatures are measured, temperature is measured in different scale. Generally in our daily life we use either Fahrenheit scale, for our simply purpose we can use the centigrade scale. Similarly for our scientific notation we use Kelvin scale. So there are the different scales used in temperature, different skills used for the measurement of temperature. They are centigrade scale, Fahrenheit scale and the Kelvin scale. In slide you can see that lower fixed point and upper fixed point. Centigrade scale 0 degree Celsius equal to lower fixed point, upper fixed point is 100 degree Celsius, and Fahrenheit scale is lower fixed point is 32 degree Fahrenheit, upper fixed point is 212 degree Fahrenheit, and Kelvin scale is 273 Kelvin for lower fixed point, and upper fixed point for that temperature is 373 Kelvin. Now, see, we can relate these three different scales. We can relate these three different scales as I show you in the board. Let us see the board. First of all, centigrade, then Fahrenheit, and then Kelvin. Fahrenheit is degree Celsius, 0 degree Celsius for lower temperature, lower fixed point, upper fixed point is that 100 degree Celsius, 32 degree Fahrenheit, 212 degree Fahrenheit, 273 Kelvin, 373 Kelvin. Now, see, the differences between upper fixed point and lower fixed point is 100 degrees, or you may say 100. The differences between lower fixed point and upper fixed point is 100. Similarly, the differences between, that is, Fahrenheit scale is lower fixed point and upper fixed point is 180, and the differences between lower fixed point and upper fixed point in terms of Kelvin is 100. Here you see that the lower fixed point means this one is the freezing of ice, or we may say melting of ice, and upper fixed point is boiling of water, vaporization of water or boiling of water. Means these two temperatures are similar. For lower fixed point 0 degree Fahrenheit, 0 degree Celsius, 32 degree Fahrenheit and 273 Kelvin are equal. Similarly, upper fixed point, that is 100 degree Celsius, 212 degree Fahrenheit and 373 Kelvin are equal. So, their differences are 100, 180 and 100. So, we can relate like this: C minus 0 by 100 equal to F minus 32 by 180 equal to K minus 273 by 100. Okay. C means degree Celsius minus lower fixed point and their differences. Degree Celsius minus lower fixed point upon their differences. Similarly, degree Fahrenheit minus lower fixed point and their differences. Degree Kelvin or Kelvin minus lower fixed point and their differences. Both are equal terms. So, we can relate these equation, and here comes like C minus 0 by 100 equal to F minus 32 by 180 equal to K minus 273 by 100. You can do the mathematical procedure for the later. Okay, let us do some numerical for this. Okay, convert 37 degrees Celsius into degree Fahrenheit. Then here given value is degree Celsius and you must have to convert into the degree Fahrenheit. So, we know the relation C minus 0 by 100 equal to F minus 32 by 180 equal to K minus 273 by 100. So, no need to take this because we just need to convert into degree Celsius into degree Fahrenheit. So, no need to take the Kelvin scale. So, I just remind you that point, and C minus 0 by 100 equal to F minus 32 by 180. C means 37 degrees Celsius minus, you can like 37 minus 0 by 100 equal to F minus 32 by 180. That is 37 by 100 equal to F minus 32 by 180. After calculating, you can get the value in degree Fahrenheit. Similarly, convert the boiling point of water in degrees Celsius to Kelvin scale. Okay. Then here is the two relation, that is degree Celsius and Kelvin, and we know the relation like C minus 0 by 100 equal to F minus 32 by 180 equal to K minus 273 by 100. So, we need to convert only these two terms. So, no need to take this one because we know that A equal to B equal to C equal to A equal to C also. Then C minus 0 by 100 equal to K minus 273 by 100, and the boiling point of water is 100 degrees Celsius. So, put here 100 minus 0 by 100 equal to K minus 273 by 100. This is 100 by 100 means 1 equal to K minus 273 by 100. Do crisscross, then you will get the answer K equal to 373 Kelvin. That is the answer. Okay, I think you all got this. Just remind this relation C minus 0 by 100 equal to F minus 32 by 180 equal to K minus 273 by 100. These are the relation between the different scales of temperature. These are the relation of the different scales of temperature, that is C minus 0 by 100 equal to F minus 32 by 180 equal to K minus 273 by 100. Now, look at the slide. In next slide, we will have the types of thermometer. There are the different types of thermometer used in our daily life, and on the basis of the thermometric liquid used in it, there are two types of thermometer. One is mercury thermometer and another is alcohol thermometer. And on the basis of working principle, there are the main types of thermometers are clinical thermometers and laboratory thermometers. Again, on the basis of liquid used in the thermometer, there are two types of thermometer. One is mercury thermometer, another is alcohol thermometer. Mercury thermometer for high temperature from minus 37 degrees Celsius to 357 degrees Celsius, and for the alcohol thermometer minus 117 to 78 degrees Celsius. And on the basis of working principle, or on the basis of where it is worked or where it is used, where we can use the thermometer, there are two types of thermometer. One is clinical thermometer, another is laboratory thermometer. The clinical thermometer means the thermometer used to measure the temperature of main body, are widely used in clinic. The clinical thermometer used to measure the temperature of human body is called clinical thermometer. It is also commonly known as doctor's thermometer because it is widely used by the medical profession. And what are its construction, how does it work? We will discuss it here. That is, a clinical thermometer consists of thick walled glass capillary tube called steam, through which mercury level rise and down or rise and fall, where we can see the temperature of the body or main body. And a thin walled cylindrical bulb, filled with the mercury is provided at the one end of the steam, and the capillary tube is sealed at the other end. That means, in the capillary tube the mercury flows. And after the uniform expansion and the contraction, that uniform expansion and contraction of the mercury, that mercury flows in the capillary tube. And just above the bulb, this one is the most important, just above the bulb there is a small constriction or kink. We may say that there is a small constriction or kink in the steam of the thermometer, clinical thermometer. Why it is so? Because it holds the reading for longer time. After removing the thermometer from the body, just like that, while using the thermometer, we must have to keep the thermometer with the touch of main body, or the temperature which is to be measured. So, after taking out from the body, it will take some time, and that mercury level will fall and will not show the actual reading or exact reading. So, to hold the reading for longer time, there is constriction or kink near the bulb of the thermometer. Similarly, the steam of thermometer is graduated from 35 degrees Celsius to 42 degrees Celsius, because no need to measure the human body temperature above the 42 degrees Celsius, or may not reach above the 42 degrees Celsius. So, it is calibrated, or it is scaled, or it is graduated from only 35 degrees Celsius to 42 degrees Celsius, and that is 94 degree Fahrenheit to 108 degree Fahrenheit. If our body shows the temperature of 100 degree Fahrenheit, then we will have the symptoms of fever. Similarly, 101 we have the symptom of fever. But if it shows the temperature above the 108, we may not be alive. So, it is not required for the thermometer to be scaled from 42 degrees Celsius, above the 42 degrees Celsius. Now, the shape of clinical thermometer is made prismatic. Why? The answer is there because it gives a magnified view of mercury inside the capillary. Means there is a small fine bore through which the mercury level rise and fall, and it cannot be viewed, or it is very hard to view if it does make prismatic, and that prismatic shape gives the magnified or enlarged view of mercury, and we can easily read the temperature detected by the mercury. Nowadays, we are very nowadays we are using this type of thermometer. It is a digital thermometer. This type of thermometers is also used to measure the temperature, and in such thermometer, thermometric liquid are not used. Different instruments like some thermometer works on the principle of infrared radiation. It detects the heat on the basis of that, and some thermometer will work on the basis of thermoresistor. So, these are the digital thermometer in which thermometric liquid are not used. It is better to use because it shows the correct reading, and the splices or the broken of that thermometer will not cause any mercury pollution. Okay. In next class, we will learn more about the laboratory thermometer and more about the human body temperatures. Till then, have a nice time. Bye. Thank you, class.